2 chapters left. Yeah, we're gonna just keep plugging right along. There are a few of you that have not taken the test. That needs to be done ASAP. Cannot be today. I've got to go help at the track meet. Tomorrow would be good. Sooner the better. Okay, so it is 4:14. Yeah, 4:14. And this is 6th period, and this is going to be Chem 11:10, chapter 12, day 1. And our objective is going to be able to properly name any given alkane. Now, I'm going to show you what they're going to expect you to do. Okay? So you just watch. Everybody just watch. Okay? Now, this is just a common alkane, and they're going to expect you to name this properly. Okay? Now, there's like 4 or 5 steps that if you follow, should always get you to where you need to go. Okay, the first thing is you have to establish what is known as the backbone. The backbone is the single longest consecutive chain of carbons you can find, no matter the direction. Okay? Now, 1, 2, 3, 4, 5, 6, 7. Okay? Can I get a longer chain than that anywhere? I can't. Now, because it's human nature, we always seem to number things from left to right, just like I did, right? I could just have easily, though, Buxton, was that you? Done what? Yeah, I could have started on the right. Okay, so I could have went 1, 2, 3, 4, 5, 6, 7. And that's actually really, really important. Because your sum, when you're done, the sum needs to be as small as possible. Now, you'll understand what I mean when I say sum. Okay? Now, this branch and this branch each have 1 carbon in them, right? Okay? They are what are known as methyls. Okay? A 1 carbon is a methane. When it's a branch, it goes from an ane to an yle. A 2 carbon branch is an ethane. But because it's a branch, it is an ethyl. Okay? Now, what this would be is this. Okay? That is what that compound is. It is 4-ethyl dash 3,5 dash dimethyl heptane. And that's what they're going to expect you to do on the test. Now, don't give me that look, Richards.
I'm looking at you. What do you want me to do?
Now, I'm going to break this down for you. Okay? The last thing is the backbone. That is what makes it what it is. Okay? The other things are the branches. Now notice, anybody know why I went 4-ethyl before I went 3,5-dimethyl? Because no. Yeah, that's why the numbers are there. Okay. That's coming off the 3 and that's coming off the 5. If I went with the red numbers, it would have been the same thing. So my sum would have been the same. Okay? E comes before M. Prefixes don't count. di, tri, tetra, they don't count. Okay? E comes before M. And then this would have a total of what? 12 or something. But you'd only do that if you were going to compare them. Okay? Now, what you do need to know is you need to know the 10 Latin prefixes. Or the 10, not the 10 Latin prefixes, the 10, first 10 or the first 10 anes. Okay? So you have methane. When it's a branch, that becomes methyl. You got ethane. You got propane. You got butane. You got pentane. You got hexane. You have heptane. You have octane. You have nonane. And you have decane. You need to know them. Okay? Numbers 1 through about 5 are pretty common. Okay? Now, most of what we're going to do today is what is referred to as acyclic. Acyclic means it's non-what? Anybody know? It's non-cyclical, which means none of them make a ring structure of any kind. Okay, we'll get into that, just not today. Okay? Now, this is what we're going to do. We're going to walk through a couple of these, talk through them, then get into some raisy handy. Okay? So, let's say I do this. Let's say I gave you that, and I gave you that, and I gave you that. Okay, so let's say I did that. Kind of ugly, but anyone tell me what my backbone is? The name of my backbone. My backbone is heptane. And we got something different. Richards.
Not the same thing, but isn't it the same? Like, there's two ways you can get that heptane. You can go straight across, or you can go down. So aren't those both 7?
Yeah, they're both 7.
So how would that affect how you name it?
Drastically. Now I'll explain it. I'm just going to see if somebody can actually get this answer right. Because that's not correct. What did I say I needed for my backbone? The single longest consecutive chain. Oh, you mean I could go 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that not the single longest consecutive chain? Doesn't matter direction. Do you see what I'm saying here? Or I could go the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9. No matter what, when I'm done, this sucker's going to be what? No name. No name. Not no name, no name. Okay, this is no name. Now, is there anyone that can figure out a giveaway as to which way I want to number this? The blue ones or the red ones? And make it kind of easy to figure out down the road? It needs to be the smallest sum, but is there a way to figure that out? Pretty simple.
This way, right? Like, start with 1 on the right side.
Start over here. Why?
Because then your branches are going.
Yeah, my branches are going to be lower numbers. I always want to start where the most branches are. And obviously there's more branches here than there is over there, right? If I would have went this way, I would have had a 5, a 7, and an 8, right? Going the other way, I've got a 2, a 3, and a 5, which is clearly going to be a lower number, right? So we've already established that I'm going to go with the red ones, right? We good with that? We understand why we're going with the red ones. Then I go back and I say, well, what do I have here? Well, this one is a what? What kind of branch is that? This branch. How many carbons are in that branch? 2. What's a branch with 2 carbons in it? That's an ethyl. Okay. 3 is a methyl. 2 is a methyl. So I end up with 2 methyl, so I know I'm going to have a what? A dimethyl, right? If I had 3 methyl branches, then I would have had a trimethyl. Okay? So, how am I gonna order this? Alphabetically. Does di count? No. So ethyl's got to come first because ethyl is an E, methyl is an M. Does that make sense? I separate numbers and letters with, did anybody notice? Dashes. I separate 2 numbers with commas. So this would be 5-ethyl dash 2, 3 dash dimethyl, no name. And the and is all one word. 5-ethyl 2,3-dimethyl nonane. Okay? I say it the way I say it so you know what's there. The dash and the commas and all that stuff. Does that make sense? Okay? So, let's do this. Let's do that. Okay? So, here we go. Can you tell me how to number it right off the bat so you only have to number it once? Left to right, starting here or there? Starting here? Right? So what's this going to be when I'm done? What's this going to be when I'm all said and done? It's going to be a heptane, right, Richards? It's going to be a heptane because I got 7 in my backbone. Okay, how many branches do I have? I've only got 2. Are they the same? Am I going to have any dis or tris or any of that? No. This is a methyl. That methyl occurs at 3. This is an ethyl. It occurs at the 4, right? So, how would I write this? 4-ethyl 3-methyl heptane. Is she right? Just like that. Richards.
Can you explain the difference between an ethyl and a methyl again?
Just how many carbons are there? Methyl has 1 carbon, ethyl has 2 carbons. And that's, so if you go back to this list, it goes 1 through 10. Does that make sense? You usually never have, for what we're doing, you never have a branch bigger than 5. Because if you do, it typically becomes part of your what? Backbone, exactly. Like that one I screwed most of you up on. Yes?
So then, how do you turn the ols into anes?
Say that again.
Well, like a methyl to a methane. How do you change that over?
If it's part of my backbone.
Okay.
Yeah, the only time it becomes an ill, a YL, is if it is a branch off your main chain. So let's do this. Here's a good example of that. Let's do this. Okay. let's do this. Okay, so who can tell me what this is going to be when we're done? It's an octane. Why is it an octane, Fish?
Because the branch off the bottom.
Because this branch is not technically a branch. That's part of my backbone. It looks like a branch, but if I go that way, I get 8. If I go that way, I only get 7. Right? 1, 2, 3, 4, 5, 6, 7, right? And I always go with the longest. Now, which way do I number this? Do I start down here or do I start up there? I start up here because that's going to make that a 2, because it's 1, 2, right? So I go 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what is this branch? How many carbons are there? Do I count this carbon? No, that's part of my main chain, right? So I've got 1, 2, 3. Well, what's 3? It would have been propane, but it is propyl. Propyl. It comes off of propane. Right? Propane becomes propyl. Exactly. Now, this is a, what's this one off my 2? It's a methyl again. Okay, so, now which comes first? Now methyl comes first. So I'm going to have what? 2-methyl dash 4-propyl octane. Just like that. Is that making any sense? Yeah?
Is propyl octane all one word?
Yes, that is all one word. Yep. Now, while we're at it, there are 4 types of carbons in any structure. Okay? You've got a primary, you've got a secondary, you've got what's called a tertiary, and you have a quaternary. Now, this carbon has, and I'll tell you, I got 3 primaries, I've got 5 secondaries, I've got 2 tertiaries, and I don't have any quaternaries. Anybody think they have an idea of what that means? Okay, so primary I got 3. I got 3 primaries. I've got 6 secondaries. I've got 2 tertiaries, and I don't have any quaternaries. Anybody think they can figure out what those words mean based upon what I'm telling you? Hannah.
Is it like how many carbons are like branched off?
Really close. It's how many carbon-carbon bonds there are. So why do I have 3 primaries? Because that carbon only has 1 carbon bond. I screwed up. I should have been 4. I forgot that one right there. Nice call. As soon as I said that, I'm like, I missed one. Right? 1, 2, 3, 4 primaries. They got 1 carbon-carbon bond. Secondaries have 2 carbon-carbon bonds. Tertiaries have 3 carbon-carbon bonds. And quaternaries have 4 carbon-carbon bonds. We haven't done very many of this except for on the last test. Remember that last test? Wasn't there a question that was like CH3 4C or something like that? Didn't we have a question? Because I know we did this on the review, and I believe it was on the test when it looked like this, right? That would be quaternary because each of these are carbons. It's got 4 carbon-carbon bonds on it. Does that make sense? Okay. Not as common here, but it could still happen. Yes.
So just looking at it, that'd be 1 quaternary and then 4 primaries?
Exactly. 1 quaternary, 4 primaries. 1 quat. Is there an R? No, I'm saying it right. Quaternary, which is kind of hard, and then 4 primary. And there are like 3 test questions on that. That should be a free 3 points. Okay? So all you gotta do is count them up. And I just thought that was a good time to throw that in there. Okay, let's do it. Let's go raise your handy on naming. Are we there yet? Yeah.
Can you do one with like 3 methyls at least? Or is that?
Yeah, let's do it.
Okay.
Yeah, let's do it. I'll start easy. Let's do that. Okay? Do that right there. Okay, we already know it's going to be a what? No. What did Garrett just ask for? 3 methyls, which makes it I heard it, a trimethyl, exactly. Then I just go and figure out what my backbone is and do the numbers, right? Let's go 5 hands. We'll start easy. 5 hands. Slap it, slap it. Every time I say that, I think of that. Bobby Boucher action. Alrighty, so I hate early outs. Alrighty. 1, 2, 3, 4, 5. Get us! You want to take a stab at this? What do you got for me?
2, 3, 4.
Okay, now, listen up. When you read these to me, read to me like I'm an idiot. So basically, talk to me like my wife does.
2, 3.
Dude, come on, Cal. You know that's a little funny. So I got 2, 3, 4, dash, trimethyl what? Heptane. Is he right? I don't know. I didn't do it, but I'm guessing he is. Yeah? Who got that right? All righty. Let's do it again. Now, let's up the ante here. Now we're going to do both. We're going to name it, and you're going to identify a couple of carbons for me. Okay, so here we go. We ready? Let's do that. Let's do that right there. This is a challenge, and then I'm gonna just number these. Let's do 1, let's do 2, and let's do 3. So what I want you to do is I want name and classify the numbers. So I classify that carbon, and that carbon as to what it is. Okay. Except let's go for 7 hands. And I'm going to be brutally honest, this one's hard. But I'm going to use it to teach a point, hopefully.
I would just do like primary, secondary, tertiary for the one.
Yeah, so the numbered ones, yeah, classify as primary, secondary, or tertiary, or quaternary. But I name it and then classify just those 3 red ones. I have 1. Bring it up here. 2, 3. I need 4 more. I just know how hard this one is.
I messed up, so it looks worse, but like it. Is it?
Oh, wow. That's a good job.
Thank you.
I didn't look at your numbers, though. I didn't look at your numbers. Yeah, so it should be 2, 3, 3. Am I going to get any more? 4, 5. Six. One more. Need a brave soul. 7. All righty. Sydney. I don't remember what number you were, but we're going to go with you. Okay? Now, before she goes, let me explain something here. There are many ways I can number this. Okay? Let's say I numbered it like this, right? Because that's right in the middle, right? That makes this whole thing a branch. You got any idea how to name that thing? No. So if I don't know how to name it, that's probably not what it's going to be. Does that make sense? Okay? So then I'm like, well, if that's not it, then I'm going to use this part of it, right? Well, if I start over here, I don't get a branch until I get to where? 4, right? But if I start somewhere over here, I get a branch at 2. Does that make sense? So, did you do that?
Yeah.
Okay, read me what you got.
On the bottom one, I have 1.
So, no, just read me your name and then we'll go from there.
2 methyl, 3 ethyl.
So, well, remember, 2 dash methyl.
Dash methyl, dash 3, dash ethyl, dash 4, dash propyl heptane.
Propyl what?
Heptane.
Heptane. Is she right?
Yes.
Is she close?
Yeah.
Yes. What did she forget? Alphabetical, right? Not numerical. So all we would need to do is take this and do what? Swap them, because she went 1, 2, 3, 4, 5, 6, 7. Right? This is a propyl. This is a methyl. This is an ethyl. Okay, so what number were you?
6.
You were 6. Who's 5? Okay, so Hannah, what do you got for number 1?
Secondary.
Secondary. This is 2 is.
Tertiary.
So sometimes they'll call it a second degree, a third degree, and then 3 is also a third degree or a tertiary. Does that make sense? Okay. Now, there are some times you just got to write it down and then look at it and say to yourself, self, is there any way that's right? Because you get like that and they get ugly, because I could have started here and went 1, 2, 3, right? But you guys don't know how to name this. Okay? It's actually called isopropyl. We'll learn that, just not today. You know, and there are lots of different things you can learn. And what you're going to understand, and this is kind of a preface thing, we are going to barely scratch the surface of this stuff, because it can get ugly. I mean, you can go from technically a 2-carbon chain to a 1,000,000 carbon chain. Think about how many different compounds I could have between those two. You know what I'm saying? Millions and millions. That's why organic chemistry accounts for 6 to 7 million different compounds. In organic chemistry, there's only about 1.5 million. So there's 4 to 5 times more organic chemistry or organic compounds than there are inorganic compounds because of the nature of the way carbon bonds. Okay? Let's do one more. Sure, Mr. Denton, we'd love to. You guys suck. Get excited, man. Yeah, that's what I'm talking about, Bingham. You're my boy, Bingham. Sorry, that was just on this weekend. I had to laugh. Nobody knows what I'm talking about. Yeah, you're my boy, Blues. Yeah, even with the B, that just worked. What? Something. You were talking. Had to be something.
Why you always gotta call us out in it?
Well, you were talking about it. I didn't want to feel left out of the conversation.
Was there other people in here talking now?
I actually don't think so. Yeah, I really don't. Sorry. Yeah.
Hey.
If other people would have been talking, I probably would have asked them too, because I don't want to feel left out of their conversation either.
Well, sorry we left you out.
I see how it is. Okay, here we go. Last one.
Can you move it up a little bit?
Oh, move it down. Sorry, I went too high. All right, there we go.
Mostly classified even too.
Nah, I do. Do we need to keep going on that, or do we understand primary, secondary, tertiary? We're good with that. Okay. See now, Rich, I like that. I like that. How you're kind of bouncing it off. No, how you're kind of bouncing it off of each other. I like that. Some of these kids wouldn't know. They can't text it to their neighbor. They can't do it. You like, sure? Okay, I got 1. Let's go to 10. I got 2. Look at that. Bingham. Told you were my boy. I got 3. I got 4. I got 5. That's what I'm talking about. Confidence is high. Going to 10. I need... Oh, and they even got the same answer. Woo, woo. 6. Dab's feeling proud of himself right now. I need 4 more. 7. 3 more. Eight, 9, 10. All righty, Dab, you're my guy. Okay. Just make sure you read dashes and commas to me. Okay.
I got 4 dash ethyl
4 dash ethyl.
dash 3, 5 dash dimethyl.
Now you said that kind of questioningly. Okay, but we'll go with it.
Dash 6 dash propyl no name.
Is he right? Just like that. Good job. You're gonna start pounding his chest and okay. And that is a good start to this chapter. Okay? Now, there's probably 10 of these on the test in some way, shape, or form. Now, they will get more complicated as we get into cyclicals and as we get into benzenes and things like that. Well, guess what? I will teach you that too. because that's what I do. And that's what they think I do. Yes, Richards.
Are we gonna have to be given the name and then draw out the up down?
That's a good question. I do not remember a specific one like that on the test, but I will check. They are actually easier to go backwards.
So it's more easy to do it like this.
This is the hardest.
Oh, this is harder.
Yeah. If they give you this and want you to, it's easy because I start right there and then I just start drawing branches of those numbers. Does that make sense? Yeah. So to go backwards, I think, is way easier than to go forwards.
So could you draw it like 100 different ways too? Could you have it not be bent?
Yeah, I mean, there's a lot of different ways. You're gonna see that they're gonna try to make them fairly uniform, as far as, you know what I mean. It's like when we first started this. I believe it was Buxton. You know, our natural tendency is to start at the left and number to the right. You know, that's probably the biggest thing you've got to realize you can't do on this. You've got to count them. You've got to look at them. You know. But to go backwards, I'm going to draw a 9-carbon chain no matter what. But you're right. I could draw it a lot of different ways. But I would draw it 1 through 9, and then I'd branch it. It would look drastically different as far as appearance, but it would be the exact same thing. So that's why. That's why it's so important to know how to number them and to know how to name them. Because visually it might look different, but if I really look at it, it's the same thing. Okay? That's good. That was actually a really good discussion.